Hello everyone, welcome back to my YouTube channel. In today's video, we are going to discuss about your operating system unit 5, which is input output management and disk scheduling. These are the topics which we study in this unit, like input output devices or services provided by them, communication techniques, what is pooling, starvation, disk structure scheduling, and disk scheduling algorithm, like see scan all of these. Read these topics we study in this unit. So let's start. The first topic will be input output devices and input output subsystems. So what are input output devices? As we all know, these are the hardware components that allows a computer to communicate with user and other systems. This is responsible for managing communication between CPU and peripheral devices. I divide this into three categories: storage devices, transmission devices, and human interface devices. The first one will be storage devices like disk and tapes. Another one is transmission devices like network cards, modems, and the third one is human interface devices, which are keyboard, mouse, and screen, etc. The services provided by them are input output scheduling, like organizing the order of input output requests to improve performance; buffering, like storing data temporarily by it being transferred; and the next one is caching, जो मैंने पहले भी बताया था, keeping a copy of data for fast memory access or quick access; and the spooling will be placing data in a buffer so device can access it when ready. The next one is input output communication techniques. These are responsible for communication between CPU and input output devices. Uh, the first one is programmed input output, like polling. The CPU constantly check whether the device status bit to see if it is ready. It is base CPU cycle basically. There is a CPU issues of commands and then waits for input output devices to complete the operation. So this is simple but waste CPU time. The next one is interrupt driven input output. Instead of CPU waiting, the device sends an interrupt signal when it is ready. This allows the CPU to perform other tasks in the meantime. So here is written: the device sent an interrupt signal to CPU. When it finishes a task, the CPU can do other work in the meantime. The next one is direct memory access, which is DMA. For high-speed data transfer, like disk reads, a DMA controller manages the data for move directly between the devices and memory without involving the CPU for every byte. Okay, this is the most efficient method for large data. So used for high speed input output and controller transfer block of data directly between the devices to the memory main memory without continuous CPU involvement. So this is DMA. This is important topic. The next one is disk structure. It is basically a magnetic disk consists of several platters that rotates, and each platter has tracks, and each track is divided into sectors. So this is structure. These are the things which are comes under this. Seek time, basically time taken to move the disk arm to the correct track, and rotational latency is basically time taken for the correct sector to rotate under the head, and transfer time is basically time to actually read and write the data. So these are the topics comes under this structure. The next topic will be disk scheduling algorithm. Basically, since access is slower than CPU processing, then operating system use algorithms to decide order of disks input output request to minimize head movement. So this is used for minimizing the seek time. The first algorithm will be FCFS, which is first come first serve. Basically, this request are handled in the order they arrive, and it is simple but can cause the head to move back and forth across the disk inefficiently. So simplest but read in result in a lot of wild arm movement. So this is FCFS. The next one is SSTF, which is shortest seek time first. The operating system pick the request closer to the current head position, and this request total seek time but can lead to starvation. For request located far from the current position, like selects the request closer to the current head position, and a problem may cause starvation for away requests. The next one is scan, which is elevator algorithm. The arms moves from one end to the of the disk to the other and servicing request along the way, then reverse direction. Okay, so this is a scan. The next one is C scan, which is similar to the scan, but when the arm reaches to the end, it immediately returns to the start without servicing request on the return trip, providing a more uniform wait time. So here is written similar to scan, but when it reaches to the end, it immediately returns to the beginning without servicing request on the way back. The next one is look or say look, version of C scan and C scan that only go as far as the last request in either direction rather than the very edge of the disk. This is the difference between scan and C scan based on some features like movement. C scan basically moves in one direction to the end, then reverse, and like scan. And C scan moves in one direction to the end, then jump back to the start. Services on return, C scan services request while moving back, and जो हमारा scan है does not services requests on the return trip. Waiting time, scan is basically high waiting time for requests at the edge, and C scan provides more uniform waiting time for the all requests. Based on efficiency, scan better throughput for some cases, and C scan more fair to all the requests regardless of positions. The next topic will be RAID, which is a very important topic, redundant array of independent disks. The RAID is basically techniques to combine multiple small inexpensive disk drives into an array to yield performance and reliability. It is divided into some categories like RAID 0, RAID 1, RAID 5 and RAID 10. The RAID 0 will be stripping high performance, like data split across disks but no redundancy is there. If one fails, all data is lost. The next one is RAID 1, which is mirroring high reliability. Data is duplicated on two disks. This is RAID 1. And RAID 5, like distributed parity, balance of speed and safety, and data and parity, like recovery info, are spread across three or more disks. The last one is RAID 10, a combination of RAID 1 and RAID 0. So these are the categories of RAID. Okay, now we differentiate both RAID 0 and RAID 1 based on some features like redundancy. RAID 0 have none redundancy, and RAID 1 is have high redundancy, like full duplication is there. So data loss complexity is low in RAID 1 and high in RAID 0. Loss of data. The next one is data safety. In RAID 0, if one disk fails, all data is lost due to redundancy, no redundancy. And in RAID 1, if one disk fails, data is safe on the other disk because of high redundancy. Okay, the next feature will be performance, very fast, like parallel read and write. You can read and write both functions to parallelly, and a slower write speed must write to both disks. Because of writing in both disks, the performance is slow in RAID 1. When we talk about storage efficiency, there is 100% no space wasted, but 50% half of the space is used for the copy. Best for the RAID 0 is best for gaming, video editing, like temporary files, but for operating systems, critical data, we go for RAID 1. The next topic will be file system interface and implementation. So this explains how the operating system physically maps the logical files onto disk blocks. Uh, Basically logical collection of related information. So we have file attributes like file name, identifiers, type, location, size, and protection. Directory structure like single level, two level, tree structure, acyclic graph. These are the directory structures of files. We have allocation methods like contiguous allocation, linked allocation, and index allocation. When we talk about contiguous allocation, a file occupies set of adjacent block if it is fast but cause external fragmentation. Like file occupies set of adjacent block fast but cause fragmentation, like we have fragments are there. The next one is a linked allocation. Each file is linked list of disk blocks, and this solves fragmentations but is slow for direct access. Okay, so each block contain a pointer. Like we study about linked list in data structure. This is how linked allocation is work. Like each blocks contain a pointer to the next block and no fragmentation, but it is slow. And when we talk about index allocation, each file has its own index block that points to all its data blocks, allowing for efficient direct access without fragmentation. So there is an index block contain all pointers location of the defined data files block, and efficient supports random access. So these are the file system interfaces and implementations. Now the next one is we talk about linked and indexed. We differentiate both of them, right? So this is essential for file system implementation. Like Unit 5 may this is very important. The linked list allocation, each file is linked list for disk blocks, right? But the pros of this is no external fragmentation is there, and cons is only support sequential access. To get to block 10 you must read block 1 to 9 if a pointer is corrupted. The rest of file is lost, right? And then when we talk about indexed allocation, each file has its own index that contain the address of all its data blocks. So the pros of this is supports direct random access. You can jump straight to any part of the file, and cons is waste of space for the index block itself, especially for very small files. The next and the last topic is file system protection and security. So the access control list is ACL, which specifies that user or system processes are granted access to object. Like you have to grant permission for the access of files. Okay. And the next one is read, write, execute bits. Simple permissions like user only can read, user only can write, and user only can execute. So these are used in systems like Linux. And also we have passwords, like protecting specific files with a key, unique keys be set unique keys for protection or set passwords for them. So all these are in Unit 5 of operating system. I hope you like this video. Thanks for watching.